Hi, let's do this GFG question, maximum index. Given an array ARR of positive integers, the task is to return the maximum of j minus I subjected to the constraint of ARR I must be lesser than ARR j. So what we need to do here, we need to maximize this difference between two indexes, and constraint is given that ARR I must be lesser than ARR of j. So in that case, what we need to do, these are the indexes, right? And let's see an example to understand it more. Uh, okay, let's see this bigger example. Here we are getting the output 6. How? Let's, like, we need to maximize the indexes, right? So we will be moving I and j as apart as possible. So let's put I here and j here. Uh, if we see that 34 is greater than 1, it is not satisfying this condition, right? So we will ignore this. Let's move to next index, which is 8 and 33, right? Now we'll see that okay, this is satisfying the condition, and let's check the indexes as well. uh, this is one index, right? And this is seventh index, if I'm not wrong. So that's going to be 7 minus 1, which is 6. So here we are maximizing this output, right? So only these elements will be taken in this case. Okay, let's solve this question. We will first, time complexity is big O(n) and auxiliary space is big O(n) also. So we can take another array, right? So I will be taking a vector. I will be taking a pair of integers, right, to store the indexes as well as the element at that index, and then I will be sorting that this v vector, right? So let's okay, let's take the index as well. Ar dot size comma index 0. Okay, let's start this loop. It will be running from 0 to n, and what we need to do here, we need to v dot push back, and we will be storing, because we will be sorting it on the basis of element itself. That's why I will store here arr I, the element, and then the index. Let's sort it now. V dot begin, sorry, comma v dot end. Now okay, let's take another loop to check. Now we have the sorted vector, right? Now we will check in this loop if the second element, which is the index, right, is lesser than a value. A value, let's take a minimum value to store the minimum index that we are encountering till now. It will be storing the minimum index. Okay, so since it is storing the minimum index, we have to assign it as int max, right? Okay, and let's take an answer variable as well, so that it's it int minimum, right? Because we want to maximize this answer, right? So it has to be this value. Okay, I dot second, it has to be lesser than minimum. Let's check if we get any value lesser than minimum. Of course, in the first case it will be lesser than. So what we will do, we will assign minimum vi dot second here, right? And if this condition doesn't work, what we will do, we will get the answer variable, and we will store the maximum value of answer, which is of course in the first case it is int minimum, right? And what we will do, we will take the index which has the current index minus the minimum index we are getting till now. So it will be giving us the difference, right? And since we are calculating the maximum of this difference, like answer in this, it will give us the answer itself, like we will return this simply. Now simply return, or maybe you can do, like if we are not able to find anything, let's just say that return the maximum of 0 slash answer, because otherwise it will return int minimum, because we have assigned it minimum value, right? So let's see if it works. Let's compile it. Okay, it's working for this case. Let's submit it. Okay, it's working. Okay, let's see, let's visualize it. I'm using this pythontutor.com. Let's see how it works. I've pasted whole thing here, and for the convenience I have also pasted some cout so that you can actually see what's going on. Let's start at this visualize execution. Okay, let's visualize it. We need to wait for few seconds. Okay, it will be taking a few seconds to run. Let's do it. Okay, let infinite loop. Visualize again. I don't know what is wrong with this. I think it should work. It was okay. Okay, yeah. So in the first, we can see array and I and index. So of course we have assigned these values. Yes, it is here, right? Let's see. Okay, I'm done running 135 steps. Something is wrong here. Is something wrong here? Okay, okay, it's working. So yeah, this was the original array, right? And this is the vector which I told you, and we've sorted it. If you can see, let me increase the size. We've sorted it, okay, on the basis of element itself. So 1 2 3 8 and then 10 and then 30. So it is sorted on the basis of element, right? Now in this loop, in second loop, we will be calculating the minimum. So firstly 8 will be the minimum. Okay, then we are getting four index, then we are getting 3 index, then we are getting 1 index. But now we are not getting any index which is lesser than 1. So it is increasing index, right? So it will store a value inside answer, right, which will be 2 minus current one and minus mini. Mini has already 1 inside it, so it will be answer will be 1, right? Now we have 6, so uh, 6 then 7, so answer will be 5 here accordingly, and then answer will be 6 here accordingly. Now we are getting the last, which is the least index, which is 0. So mini will store 0 and answer will be 6 according to this loop. And that's how we will return maximum index. Thank you.